a smart recycle solution.
So what is the project?
It's called Smart Recycle.
Okay.
We have a conveyor belt basically powered by Raspberry Pi and a couple of Lego motors in the back. And we have a Jetson Nano, which is running our machine learning model. It's got a camera hooked up to it in the mid front. So the idea is to basically sort trash from recycle, given an object is in front of it. For example, let's put the soda can. It identifies it and basically pops up like saying it's 96% recycle, and then it's going to move it to this recycle side of things. Say now we have a baseball, we put it and it's going to pick up as baseball with 99% confidence, and it's going to trash on that side. So what we did was we basically categorized certain items like coffee cup, soda can, aerosol can, or baseball. But anything which comes in new, like we have an aerosol can here which doesn't really work in a weird angle. It's with a low confidence. So what we're looking for is basically, let's check. Yeah, what we're looking for is a confidence of 70%. So if we get a confidence of 70%, the model knows what to do. So it's going to go do it. But since the confidence is 54%, it's not going to do anything. It waits for the user to give feedback. So for example, if you go here, it's waiting for a feedback. You know it's an aerosol can, you know it's trash. So what you can do is basically say, hey, it's an aerosol can, or you can label it yourself in something.
And based on that,
this and this. Push this. What it does is it's going to force this to go trash. At the same time, it takes the picture, stores the picture, and labels the object with an aerosol can. So when we retrain the model later, it picks up all the data.
So it doesn't do the real time.
It's not real time because the model takes 15-20 minutes to build it because it's a small category. But as you add more categories, it's going to take more time to build it, and it's pretty quick just because of the fact that the model is actually here. We are training the model using SageMaker in the cloud. Once the model is ready,
now this is disconnected to the internet.
This is disconnected. So if we actually take on the internet, basically all these two devices are in sync in the same locally, and they just need to talk to each other. They're all set to go. Except this is a web app, so it's on the internet. It's on the internet, but the Sky is both these are.
And what is the architecture that you're using?
So what we have is it's a simple architecture, right? So we're using SageMaker to do the modeling, train the model, deploy it on the Jetson Nano, which is the camera station here. We have a recycle station here, which is what is...
And this deployment is automatic or...?
No, we got to go onto this box, pull it down, but there are ways to do it. There are multiple ways to do it. For this one, we haven't picked that one out. And we use IoT code to exchange messages between each other using MQTT protocol, and since it's green grass, there's actually a Lambda running on this Jetson Nano in a continuous stream.
But if you lose the connection, this whole thing will still work?
Yes. So these two are in the green grass code. That means they're local. They can communicate with each other very easily. So that's it. All the other stuff, like what you see on that dashboard, is a Kibana dashboard. Any message is passed through that very easy spirals with that just to track what many items are there. And then we use all the images are stored in S3. They're labeled so that we reuse those items, go through that model, then we know for sure with more confidence that this is an aerosol can, even at a weird angle. So,
and how do you use Amplify?
We're using Amplify just to bring the web app. The web app Amplify helps you. It's a framework which you can use to help talk to AWS services. In this case, the MQTT protocol to subscribe and publish both. So whenever this guy sends a message, it's actually being listened by that and that as well because it's on an MQTT topic. And also when you send the feedback, it's actually publishing the topic which this guy is listening to. So there's a synergy over here in terms of content.
This is good. It looks cool.
Thank you. Yeah, if you like project,
sure. Do you have any weekly or
no, so we have an email address where we take questions on the recycling part of it. But we will put all these projects on GitHub.
something completely random.
So where you can have the architecture diagram, FAQ, if you want to reach us for any questions.
Good luck.
And thanks so much.
It's recognizing the language. As soon as it recognizes the language, it will start the conversation. So you greet it in English, and you recognize, oh, is it English, Hindi, Arabic?
And what is the latency for that?
For English, it's pretty quick. So it looks like it didn't recognize your language. Let's try it again.
Otherwise, it will. Yeah, that's fine. So, can you explain the architecture a little bit?
Yeah, sure. So this is the architecture. The way it's built is, as soon as you speak a greeting, you move a file to the audio file to S3, trigger a Lambda function that translates it into a text using transcribe service. Once we get the text, we figure out what the language is. Right? So we transcribe in all the languages and we see where the greeting is coming from. Once we detect that, then we translate the greeting message into that language. So if it's not English, if it's something else, then we translate it, and then we generate an MP3 file, an audio file, send it back to Raspberry Pi using IoT. And then it will tell you output.
So this is the whole cycle.
This is one cycle, one conversation, and then the next conversation will go to this, where it will ask you where you're visiting us from. You tell the city name, it figures out, it calls Open Weather API to figure out what's the weather there versus weather in Vegas.
So this Lambda function is just programmed to do one thing?
Yeah, all these are programmed to do different things. So like this is to detect the language, this is to find out weather, this is to find out restaurants.
So if you would like to add new features, so you will have to deploy a new Lambda function?
If like new conversation, we can deploy new Lambda function, or depending on what the new conversation is, we can integrate in the same Lambda function.
And this is using the same technologies after that?
Yep, these are all, the workflow is entirely same. Yep, here, same technology. So these are the managed services from Amazon? These are all, everything is serverless, so you don't have to manage infrastructure, pay as you go model, all those things.
Alright. Okay, thank you so much.
Yeah, sure.
Good luck.
Thank you.
Hello sir, how are you? Can you explain the project a little bit?
Yeah, so it's a schedule sorter. So it sorts the schedule based on the color. There is a Raspberry Pi camera here, which is connected to Raspberry Pi, which is running the code to detect the colors. Once it detects the color, it sends a signal to the servo motor here to turn the bins and catch the right color. Right? For example, if I put in orange here, it's going to turn and catch the orange one.
What happens if you put two colors here?
It will fall in one of those.
And what is the architecture that you are using?
So architecture is, we are using AWS IoT services to manage this Raspberry Pi environment with this conveyor and all. So this pretty much can run on its own. But imagine this in an industrial scenario where you have thousands of these running and you want to control them from a single place. So that's where the IoT services come in. So using this you can deploy software to multiple devices at the same time, software changes. You can collect information from those devices through MQTT client, through IoT topics, and visualize it, send it to Elasticsearch and visualize it using Kibana like this one.
So this is the Kibana dashboard.
At the same time, users can control the state of the devices running from let's say a web UI like this. So you can go here, you can change the state like on, off, or the color you want to sort or not sort. So that hits the API gateway, and there it will trigger a Lambda function which will go and update the shadow. A shadow is a desired state of your device, image of a desired state on the cloud. So whenever the device comes online, it's going to pull the shadow. It will do the comparison and find the delta between the current state and the desired state, and then make that changes. So you can control thousands of devices like this by just running this completely serverless.
And this can work in offline as well. When the code is synced with the green card. Cool. Good luck. Thank you so much.
Okay.
So that is your I don't know what we have done. I don't think we have any data there. I think we will upload. I'm not going to AIML except like that.
Okay. Take your hand up and down. And thank you. like a
Raspberry Pi, yeah.
This controls the red and blue cars. We have a real-time board central Detroit. So if you make moves,
Database is on the
forward, right,
our GitHub site
right,
is over there
left,
as well.
based on the
Underneath
direction
the
of the
game,
car.
so you can get our code off of the GitHub site on AWS samples.
Alright, so what is the project?
If you move
So this is a IoT-based, AWS IoT-based tag, game of tag. So we've got a joystick controller with a Raspberry Pi, and the Raspberry Pi knows how to communicate with an endpoint, an MQTT endpoint in the AWS cloud to send messages to AWS IoT Core for ingestion. So there's one of these, so we control the red car and the blue car here in the MGM. We have the exact same setup over in the Aria, and they have a joystick and a controller that controls the white car and the black car. So it's a turn-based game, so all four cars have to submit a turn into the system. And then what we do is we calculate the validity of all those moves, right? So all of the Pis send their messages through IoT Core, and it executes a series of lambdas, basically. So the board microservice determines if the moves are valid, and if so, where's the state the vehicle is going to be. So to represent the game board, we've decided to build two different things. We're kind of trying to describe like the distributed nature. What
So
we
this
do with IoT.
board is where?
This is in Detroit, Michigan.
Alright.
So that LED board.
So you're remotely controlling the...
So we're controlling the state of virtual game pieces with the joysticks. This is just a representation of where those game pieces exist on the grid on an LED board out of our office in Detroit, Michigan. So we've got two representations of the game board. One of them's here on that LED board. The other one is this web user interface that you see up there. So two different ways to kind of pull the same data. So the LED board basically reads those MQTT messages. It's stateless. So it's just saying, I'm blue moves right, red moves right, red moves up, down, etc. So that's one way.
So what is the real world use case for this one?
So we are the team that built this, a lot of us, we have a lot of customers in the Midwestern part of the United States. They're like industrial manufacturing type customers. So many of them are starting to explore IoT and the Internet of Things as far as what can it do on their manufacturing floors to like enable better business outcomes, things like monitoring. So if you think of each one of these as like a temperature sensor, for instance, on a machine that's on a manufacturing floor, it might be reporting into the cloud its current status, right? So I'm running at 50 degrees Celsius, I'm running at 52 degrees Celsius. All that data can flow into your AWS cloud, and you can run analytics on that data. So that's, at its base level, that's like the use case that I talk to my customers about a lot.
Alright, thank you so much.
Yes, you're very welcome. Have a good day. So take stickers if you want. Give us feedback with a QR code.
I'll get it from you. Thanks.
Thank you.
Hello sir, how are you?
Good. How are you? Kyle? Nice to meet you.
Nice to meet you. So what is the project?
Lego Zombie.
Okay. So what does it do?
What does zombie do?
Zombie kill each other
machine learning model.
or other people?
Zombie person is to catch you, right? It catch you, so we'll follow you, catch you, and maybe eat your brain.
Okay.
So what it does, as this zombie will try to find the victim, which is a Darth Vader.
Okay.
When it sees it, it will go towards it.
So it will identify it.
Yeah, it's more like we will seize it and go to it. It's more like object tracking.
So if I go this one, so it will be a victim as well.
It will, because when we train it, it's basically, it will find any, this is a simulation environment
like this,
when we train.
it's trying to find
When we
something
train,
that's a contrast
basically
between the
look-
background
just
And
think
what you
some
see, so
obvious
I can
contract.
add
The
kind of
black
like-
thing have the most contract.
Okay.
Now if this is nothing
Hold
here,
it over here. Let's put it over here.
yeah, do it here. So that they also
And
track
eventually it'll
photo.
start, it sees the contrast.
It goes
and starts
around,
tracking towards
so you can
Okay.
save it
So there's
and
no
go for it.
recognition or anything happening in this
Yeah.
case. It's purely just takes the image, reduces it,
Now
has
they
this
got it.
contrast.
Now
with
they
the
look for the
light,
next victim.
Okay.
So
sends
just
an
look
action
around.
command to
So
this
this
robot
is
to tell it.
autonomous driving,
And also
powered
in order
by
to
model
interact with
trained
the
by
robot, to
reinforcement
make it,
learning. That's
something
the
you can
idea.
command and
So does
on-
it, so
based
it
on our
touch
voice,
the boundary or it will
can
come
go
back
Alexa.
without touching?
These are the
Lego zombie.
touch sensor.
Okay.
So when you hit the boundary, they'll back up a little bit and search another
Joystick.
direction. Now we are changing to a joystick mode.
So you got the joystick there. So
Basically, we are
before commanding it, it triggers a
the
lambda
model
function.
to the
Lambda
inference,
function, and it's the
tell what to go.
shadow
Now we're
of
in the
Raspberry
joystick
Pi.
mode. Right?
And
Joystick
then
is
that relays another message to this robot.
So
to
you are
change
controlling this with the joystick now.
and then we can
There we
control it
go.
with the joystick.
Yeah.
Okay, you can see the wireless receiver for the controller at the back there. That's plugged into the Raspberry Pi. It sends that input from the joystick to the ROS message. So this ROS is robotic operating system. And that topic is also, it's subscribed to that topic on this, and then it navigates. But then we can also do a few other tricks like this. Alexa,
So this is IoT
open Lego
competition
Zombie.
or what is the name of it? It's just a showcase. Just showcase.
Yeah, yeah,
So
yeah.
you're not competing in any.
No, I'm not.
This is a pre-programmed little
This is about
script
just to
when
show
we
that
issue that
first
command,
how to do reinforcement learning for autonomous driving. Right? Second, how you integrate with the Alexa skill and
So
IoT
that's still part of the dance. You'll see now
for
it
this
does the-
robot to
does the
take
circle.
the voice command.
just
Now
a
the
few
dance
little
mode.
touch
We
scripts on
pre-programmed the dance move. Right?
And there's no
trigger-
zombie left, so
square.
it will dance.
Exactly.
All right, thank you so much.
Sure,
Have a good
thank
day.
Yeah, this one we've got all the details.
Yeah, sure.
Yeah, and a roll fly.
Okay, thanks.